About half of the solar radiation that strikes the top of the atmosphere is filtered out before it reaches the ground. This energy can be absorbed by atmospheric gases, reflected by clouds, or scattered. Scattering occurs when the light wave strikes a particle and bounces off in some other directions. About 3% of the energy that strikes the ground is reflected back into the atmosphere. The rest is absorbed by rock, soil, and water and then radiated back into the air as a heat, or long-wave radiation. These infrared wavelengths can only be seen by infrared sensors. It's not visible to our eyes. Because solar energy continually enters Earth's atmosphere and ground surface, is the planet getting hotter? The answer is no. Although the next section we gotta contain some exceptions, because energy from Earth escapes into space through the top of the atmosphere. If the amount that is equal to the amount that comes in, then average global temperature stays the same. This means the planet's heat budget is in balance. What happens if more energy comes in than goes out? If more energy goes out than comes in? Think about that. To say that Earth's heat budget is balanced ignores an important point. The amount of incoming solar energy is different at different latitude. Remember that the planet circulates its sphere, the solar rays get directly over the equator, oblique in the poles, so difference between land and water distribution, think about that. So where do you think the most solar energy ends up and why? Where does the least solar energy ends up and why? The different solar energy received at different latitude drives atmospheric circulation and consequent ocean circulation. The exception, the Earth's temperature being in balance, is caused by greenhouse gases. But first, the whole of greenhouse gases in the atmosphere must be explained. So greenhouse gases warm the atmosphere by trapping heat. Some of the heat radiation from the ground is trapped by greenhouse gases in the troposphere. Like a blanket on a sleeping person, greenhouse gases act as insulation for the planet. The warming is caused by insulation. Greenhouse gas is called the greenhouse effect. Greenhouse gases are the component of the atmosphere that moderate Earth temperature. So greenhouse gases include CO2, H2O, water, methane, O3, ozone, nitrous oxide, NO and NO2, and chlorofluorocarbons, the CFCs. All are a normal part of the atmosphere, except the CFCs. Different greenhouse gases have different abilities to trap heat. For example, one methane molecule traps 23 times as much heat as one carbon dioxide molecule. One CFC12 molecule, a type of CFC, traps more than 10,000 times as much heat as one CO2 molecule. Still, CO2 is a very important greenhouse gas because it's much more abundant in the atmosphere. Human activity has significantly raised the levels of many greenhouse gases in the atmosphere. Methane levels, for example, are about 2.5 times higher as a result of human activity, and carbon dioxide has increased more than 35%, and CFC have recently existed, so we don't have a statistic about that. What do you think happens as atmospheric greenhouse gases levels increase? More greenhouse gas trap more heat and warm the atmosphere. The increase or decrease of greenhouse gases in the atmosphere affect climate and weather the world over. Once the visible solar energy is absorbed by the Earth system, being the clouds, the free atmosphere, or at the surface, it is transformed from electromagnetic energy to heat energy. This absorbed energy either rises the surface temperature or evaporates surface water to create atmospheric water vapor. An object has a temperature higher than the surrounding. then we lose energy at the surrounding by infrared radiation, but can be detected by absorption by human skin. A heating element in the electric oven radiates from both infrared and visible radiation if it is glowing. If the current is turned off, it gradually loses its glow, its visible radiation, but continues to emit infrared radiation, which can be felt by a hand close to the heating element. The same thing we'll talk about grills. The Earth compared with the outer space is very warm, so it radiates energy away to outer space at a rate that is proportional to the fourth power of the temperature. Some of this energy radiated from the surface of the Earth is directly lost to the outer space, while some is absorbed by gases and clouds in the atmosphere, the greenhouse gases. This absorption of infrared radiation by the planet's atmosphere, as you know, is called the greenhouse effect. So the nitrogen, the dominant gas in the atmosphere, does not absorb infrared radiation, but oxygen, the second most abundant gas, does absorb in certain wavelengths region. The daily cycle of the air temperature. Because the Earth rotates, income solar energy varies significantly. During the day, net radiation is positive and the surface gains heat. At night, net radiation is negative and the surface loses heat by radiating it to the atmosphere and space. This results in the daily cycle of rising and falling air temperatures. Although daily insolation net radiation shows similar daily patterns, negative to positive to negative, they differ in magnitude. Insolation is a strong determiner of net radiation. Air temperature responds by generally increasing, while net radiation is positive and decreasing and when it's negative. In both cases, in the mid-latitudes, insolation net radiation are linked to seasons and the length of the daylight period as opposed to the nighttime period. Daily insolation tends to peak at noon, as does net radiation. Net radiation is positive for the entire 24 hours period in the summer, while it is negative in the winter. Daily insolation is much greater in summer because the sun is higher in the sky and the daylight period is much longer than in the winter. So the minimum daily temperature usually occurs above 1/2 hour after sunrise. As net radiation becomes positive, the surface warms quickly and transfers heat to the air above. Air temperature rises sharply in the morning hours and continues well after the solar noon insolation peak. By early afternoon, the temperature rises level because of large convection currents moving much of the warm air upwards away from the surface. By sunset, the temperature is falling rapidly and continues to fall at a decreasing rate through the night. The ground temperature at the surface area on average more extreme than air temperatures above the surface. So we'll talk about latent and sensible heat energy released and absorbed by the atmosphere. So let's discuss them. Latent heat is the energy absorbed by or released from a surface during a phase change from a gas to liquid or a solid or vice versa. If a substance changes from a solid to a liquid, for example, the substance needs to absorb energy from the surrounding environment in order to spread out the molecules into a large, more fluid volume. If the substance is changed from something with lower density, like a gas, to a phase of higher density, like a liquid, the substance gives off energy as the molecules come closer together and lose energy from motion and vibration. So this process releases energy. For example, when water is boiled over a stove, energy is absorbed from the heat element and goes into expanding the water molecules into a gas, known as a water vapor. When the liquid water is put in the ice cube trays and placed in the freezer, the water gives energy as the water becomes solid ice. This energy is removed by the freezer system to keep the freezer cold. So if you have a very sensitive thermometer, probably you're gonna notice the temperature inside the freezer is gonna increase a little bit when you put a new ice tray over there.
Latent heat versus sensible heat. Latent heat and sensible heat are two types of energy released or absorbed in the atmosphere. While latent heat is related to changes in the phase between liquids, solids, and gases, the sensible heat is related to the changes in temperature of a gas, liquid, or solid without a change in phase. For example, if the substance is changing from a solid to a liquid, like an ice cube melting, the ice needs to absorb energy, or latent heat, from the surrounding air in order to spread out the molecules. On the other hand, if the substance is a gas, changing to a phase with a higher density of molecules, like a liquid, latent heat is released, causing the molecules to come closer and release more energy. Sensible heat, alternatively, is the energy moving from one system to another that changes the temperature rather than changing the phase of a substance, such as the heat that can be felt standing outside on a sunny day.